Hi 7th graders, it's Mrs. Trombley. It is time for lesson 2B.6, solving two-step equations. The difference between one-step and two-step equations is two-step equations have two steps to solve them. I know, pretty crazy and tricky. Alright, so the goal is still the same. We want to get the variable by itself on one side of the equation, and to do that, you basically have to undo whatever is being done to it. And just like in regular math problems with order of operations that you learned back in the day, order of operations still applies with this, but what we want to do is we want to undo things, so we have to do reverse order. Think of it as working backwards. So what I mean is, in this equation here, 2y plus 3 equals -9. This is a two-step because there are two operations going on. Y is being multiplied by 2, and then we have addition going on as well. So in terms of the order of things happening to this y, the first thing that happens to y is it's being multiplied by 2. After it's multiplied by 2, then you'd add 3 to it. So when I say to isolate the variable, you have to undo what's being done in reverse order. I mean, if the first thing you did was multiply it by 2 and then add 3, then the first thing you want to undo is the adding 3. So step 2 is what you want to take care of first. And to undo adding 3, yep, you guessed it, to solve it, you would subtract 3. And remember that subtracting 3 is the same as adding a -3. When you keep change it. And in order to undo this multiplying by 2, we learn that you divide by 2. So basically you're undoing what's happening to the variable in reverse order. What it looks like, stepwise, you still draw your line down from the equal sign, so you remember to do whatever you do to one side, you do to the other. And step 1, it says we're supposed to add a -3, so we'll add a -3. When you add a -3 to this side, the 3's cancel out because it's a 3 and a -3. Additive inverse, gone. 2y is left. -9 plus -3 is -12. Now when we were solving one-step equations, at this point you were done, because you just had y by itself. Right now, y is not by itself. It has a 2 in front of it. That means y is being multiplied by 2. To undo that, right here, we're going to divide by 2. 2 divided by 2 is 1. 1y is y. And -12 divided by 2 is -6. So, two-step equations, two steps to solve it. We had to add that -3, then we had to divide by 2. So basically, the whole scheme of steps is listed out for you like normal. Number 1, yes, you will keep change by adding the opposite. And basically what you're doing first is you're isolating the variable term. So variable terms are separated by addition and subtraction signs, right? So your first step is to get the term with the variable by itself, by adding the opposite of whatever's being added to it. Then you're either going to be left with a multiplication equation, which you'll have to divide to solve it, or you'll be left with a division equation, which you have to multiply to solve it. Finally, check your answer using substitution. Alright, so we're going to do a whole bunch of examples so you can become experts at the two-step. Alright, draw your line. Alright, so when I say variable term, this 2x right here, that's the variable term. And I want that by itself first. So in order to get 2x by itself, I need to get rid of this 12 that's being added. And you can get rid of a 12 that's being added by adding the opposite of it. Because 12 plus -12 is 0, and 2x plus 0 is 2x. Now we're going to solve this out on the other side. 4 plus -12 is -8. We're not done because that 2 is being multiplied by x, and I want x alone. So I need to undo multiplication with division. 2 divided by 2 is 1, 1x is x, and -8 divided by 2 is -4. Now when you're checking these, you check them the same way. You're going to plug it back in here. So when you go to plug this back in, if x is -4, then that means that 2 times -4 plus 12 should give me 4. That's how you check it. So 2 times -4 is -8. And -8 plus 12, that is 4. And 4 does equal 4. Last time I checked, it was true. 4 equals 4. So basically, you plug it right back into the equation, make sure one side still equals the other. Alright, let's keep going. Just keep swimming. Draw your line. This one's subtraction, so I'm going to keep change at the opposite. So now I'm dealing with a -12 here. Negative 3x is my variable term. I want that by itself first. That means I need to get rid of this negative 12 that's being added. I'm going to add a positive 12 because that cancels out a negative 12 when it's being added. It's true. Negative 3x is left. Negative 16 plus 12 is negative 4. Alright, I'm not done because the x has a negative 3 next to it, and that won't work. So I need to divide by negative 3 because that's how you undo multiplication. Negative 3 divided by negative 3 is 1. 1x is x. And we're left with 4/3. It's a negative over a negative, so it is positive because when you divide two of the same signs, you get a positive. And instead of 4/3, I would really like you to say 1 1/3 because that's what 4/3 is equivalent to. And again, you can plug that right back in to check it. If you're checking it with your calculator, I would be typing in negative 3 times 4 divided by 3. If you type in 1.3, 1.3 is not the same as 1.3 repeating. So if you do have a mixed number, I would type it in as an improper fraction. Alright, moving along. We've gone over a ton of how to check it in class, so if you have more questions about how to check it, happy to go through it with you. I'm not going to end up checking every single one of these because I would like to finish this video sometime today. Alright, I'm going to draw the line, and here I have a subtraction sign. I need to keep change that. So now I have a negative 5c. It's okay that it's second. It doesn't always have to go first. It's not a big deal. It's no big deal. This 9 needs to go because it's on the same side as that negative 5c. This is a positive 9. That means I need to add a negative 9 to make it go away. So 9 plus negative 9, gone. I'm left with not 5c, but negative 5c, because we had to keep change that. Negative 16 plus negative 9 is negative 25. In order to, whoa, my pen just went flying. In order to get rid of this negative 5 that's being multiplied, we're going to divide both sides by negative 5. And c is a positive 5. And again, when you go to check this, you would take 9 minus 5 times 5, enter, and it'll say negative 16. Or you could type in 9 plus negative 5 times 5, because adding a negative 5 and subtracting 5 are the same thing. And yes, your calculator knows order of operations, so you can type it in just as it appears if you're using your calculator to check. Alright, next page. Here we go. Maybe you're moaning and groaning because you didn't realize there was a whole other page. There's actually another page after this. Little math stories in it. Not story problems, math stories. They're so nice. Draw your line. Okay, this is subtraction. I'm going to keep change. Notice the variable term is on the right. That's okay. It doesn't always have to go on the left. There's not a law that says that. So I want 4p by itself first. So I'm going to get rid of this negative 7 by adding a positive 7. Those are gone. 4p is left. And now I have negative 15 plus 7. That's negative 8. Because when you are adding unlike signs, you have to subtract and take the sign of the greater digit. To get rid of this 4 that's being multiplied, I need to divide by it. So p is negative 2. Because negative 8 divided by 4 is negative 2. And again, to check this, all you would have to do is plug negative 2 in for p. And ask yourself, is 4 times negative 2 plus negative 7 negative 15? Well, negative 8 plus negative 7 is negative 15, so it works. Just writing that down like that and not actually typing it in your calculator or typing it into your brain does not make it right. So make sure that you're not just writing this out and saying, yep, that looks right. Actually do it. Make sure it works. Alright, next one, draw your line. This is subtracting 10x, so I need to add a negative 10x. Alright, this negative 10x needs to be alone first. That means I need this negative 3 to go away. So I'm going to add a positive 3 because that will cancel it out. So negative 3, positive 3 gone. Negative 10x is what's left. Because we keep changed it. Minus 10 means it's a negative 10. 37 plus 3 is 40. Now I want negative 10 to go away. It's being multiplied, so I'm going to divide by it. And negative 10 divided by negative 10 is 1. 1x is x. 40 divided by negative 10 is negative 4. And voila, you are done with that one. Alright, moving along to the next one. Draw your line. Change your sign. I'm a poet, and I didn't know it. Alright, here's 1.4n. That's what I want to be alone first. So I'm going to add a positive 300ths to each side, because that's how you cancel out a negative 300ths. 1.4n is left, and negative 11.65 plus this 300ths is equal to negative 11 and 62 hundredths. Because remember, you have to subtract the digits and take the sign of the greater when you have one of each. 1.4 next to n means multiplication, so I need to undo that with division. Because any number divided by itself, even decimals divided by themselves, are 1, and 1 times n is n. Now all you have to do is take negative 11.62 and divide that by 1.4, and when you do, you get negative 8.3. Not positive 8.3, negative 8.3. Signs matter. Alright, next I have a division two-step. So you've been dealing with multiplication two-steps so far. This is a division one, I can tell, because my variable term is being divided by something. It's the same steps here, okay? I want the variable term alone first. That means whatever's being added to it, the constant, needs to go away. So to get rid of adding a positive 6, I'm going to add a negative 6, because 6 plus negative 6 is 0. And m over 2 plus 0 is m over 2. 10 plus negative 6, or yes, 10 minus 6, because it's the same thing, is 4. Now, when we had 2 times m, we had to divide by 2 to get rid of it. If I have m divided by 2, I need to multiply by 2 to get rid of it. Remember, we talked a lot in class about the fact that this is really 2 over 1. You're cross-canceling. You're left with m divided by 1, which any number divided by 1 is itself. And 4 times 2 is 8. And now you're done. To check that, it's as simple again as plugging it in. So if we're saying m is 8, then plug in 8 for m. And 8 divided by 2 plus 6 should equal 10. 8 divided by 2 is 4. 4 plus 6 is 10. We are correct. Alright, next, draw your line. This is a subtraction one, so I need to go ahead and keep change. I'm going to add the opposite here. I need n over 5 by itself first. So I'm going to add 2 to each side to cancel out a negative 2. N over 5 is left. Negative 10 plus 2 is negative 8. Now I need dividing by 5. I need that 5 to go away. And when you divide by 5, to undo that, you just need to multiply by 5. Those cancel out. N is left, and negative 8 times 5 is negative 40. And again, you just plug it back in. Negative 40 divided by 5 is negative 8. Negative 8 plus negative 2 is negative 10. I'm not just making this stuff up. It actually works. Alright, next one. This time the variable term is second, and it's being subtracted. And you need to remember now, when you keep change, if you're trying to get the variable by itself, that negative should go with the denominator. It just saves time. It doesn't really matter where you put it, but if you put it with the top, you're going to give yourself an extra step. So we keep change it. We put the negative with the 3. I need the 5 to go away because x over negative 3 is my variable term, and that's the first thing I want by itself. So to get rid of this positive 5, I'm going to add a negative 5. I'm left with x over negative 3 because those are canceled, and negative 7 plus negative 5 is negative 12. Now, to get rid of dividing by negative 3, we're going to multiply by negative 3 because that's how you undo division. Those cancel out. I'm left with x. Negative 12 times negative 3 is a positive 36. And again, you plug it right back in there. Your calculator knows order of operations. If you're using your calculator, you would just type in 5 plus 36 divided by negative 3. Or if you're using your brain, you would say 36 divided by negative 3 is negative 12. And 5 plus negative 12 is negative 7. It is right. Alright, next. This time the variable term is on the right-hand side, and we said before there's no law against that. It's allowed to be there. But now I need to get rid of a negative 5 because that's what's on the same side as the variable term. To get rid of a negative 5 that's being added, we add a positive 5. Negative 5 plus 5 is 0. 0 plus y over 3 is y over 3. Negative 9 plus 5 is negative 4. Now to get y alone, I need to undo dividing by 3. We undo division with multiplication. And whatever you do to one side, you have to do to the other. So those 3's are gone. Y is now by itself, a loner, a rebel without a cause. 3 times negative 4 is negative 12. And now we're done. I like it, so I'm going to put a ring on it. Huh. Alright, next. Draw your line. Change your sign because I'm subtracting 8. I want to add a negative 8. This is my variable term. I need negative 8 to go. So I'm going to add a positive 8 to each side. So those cancel out. Right here, see how there's that negative sign in the middle? I'm going to rewrite this as p over negative 5. Because remember, I had encouraged you before to, if you see that negative sign in the middle, to put it with the bottom when you are solving equations. Alright, now I need to take negative 5.6 plus 8, subtract the digits, take the sign of the greater. It is 2.4. In order to get rid of this negative 5 that's being divided, yes, you guessed it, I'm going to multiply both sides by it. So after those negative 5s are gone, I need to take 2.4 times negative 5. And when you take 2.4 times negative 5, you get negative 12. To check it, you plug negative 12 in for p. There is a negative sign in the middle there that we did put with the bottom. So I would say negative 12 divided by negative 5 plus negative 8. It will give you negative 5.6. This is like the 6th time I've done this. So I know it's right, but that's how you check it. All right, last one of these. We're going to draw our line. Here's my variable term, 2/3 x. I want this 6 that's being added to go away. So I'm going to add the opposite of it. Those are gone. 2/3 x is what's left, and negative 12 plus negative 6 is negative 18. Okay, this is where everybody gets a little confused. I'm not adding 2/3 to x, so adding a negative 2/3 isn't going to help. Remember we said when we were solving one steps with fractional coefficients? If I have a fraction right next to the x, it means 2/3 times x. I could divide by 2/3 to get rid of it, and that would work. It's true. But when you divide fractions, don't you do keep, switch, flip? So instead of saying divide by 2/3, can't I just multiply by the reciprocal? Because that's what division of fractions is. Yes, Mrs. Trumbull, you can. So when you see you have a fractional coefficient, that number in front of the letter is a fraction. All you have to do is multiply by the reciprocal, and that will get you x by itself. Because, think about it, these 3's will cross cancel. Those 2's will cross cancel. You'll be left with one x, which is x. But x isn't negative 18. I have to take negative 18 and also multiply that by 3/2. Whatever you do to one side, you have to do to the other. So I'm going to cross cancel here too. This negative 18 and this negative 2 I can cross cancel. So 2 becomes 1. Negative 18 divided by 2 is negative 9. I'm left with negative 9 times 3, which is negative 27. And 1 times 1, which is 1. So I'm just going to leave it just like that. To check this, if you're using your calculator to check, you would take 2 divided by 3 times negative 27 plus 6. And yep, you'll get negative 12. Alright, 4 little math stories, and then we can be done. I know I'm exhausted too. I just got home. Okay, so for this, when you're writing equations for 2 steps, there's going to be 2 operation words within this. So right here, it says 6 less than. Those words less than, you know, mean subtract. And it says 4 times. That means multiplication. And amount x is equal to negative 30. So I know this is a 2-step equation because of the 2 operation thing. So if I want to show 6 less than 4 times in amount x, 4 times in amount x looks like 4x. 6 less than that means I'm taking 6 away from it. And you might be thinking, why isn't it 6 minus 4x? If it's 6 less than something, doesn't that mean 6 less than, you're taking 6 away? So I need to take 6 away from whatever that amount is. So what we talked before, whenever you see the words less than, it means the order gets flipped around. Alright, and then I see that word is equal to, so there's my equal sign, and it's negative 30. Once you have your equation, then yes, we get to solve it. Draw your line, change your sign. I want 4x by itself first. So to get that 4x by itself, we can add 6 to each side. 4x is equal to negative 24, because negative 30 plus 6 is negative 24. We're going to divide both sides by 4, because that's how you undo multiplication. And negative 24 divided by 4 is negative 6. Voila. Alright, next one, it says the product of. So we know product means multiplication, and I want the product of what? Of negative 3 and a number y. So to show the product of negative 3 and a number y, that would mean negative 3 times y. And now it says I want to increase that, that's addition, by 14. So if I'm going to take the product of negative 3 and y and increase it by 14, it says that that is negative 7. Voila, no order switching here because I want to increase by 14. That means take what you start with and increase it by 14. And now we're ready to solve it. Draw your line. I want 14 to go away because that's what's on the same side as my variable term. I'm going to add a negative 14 because that's how I cancel out a positive 14. You guessed it. Negative 3y equals, yes, I'm not trying to do this on purpose, but it is negative 21. I'm sick of that number, are you? I'm sure. All right. We're going to divide by negative 3. That's how you undo multiplication. And negative 21 divided by negative 3 is a positive 7. All right, we're almost there. Next one. It says the quotient of. Quotient means division. The quotient of what? I want the quotient of a number n and negative 5. So the quotient of n and negative 5 is n divided by negative 5. And I want to decrease that. That means subtract. Decrease it by 8. And it is 12. So this would show the quotient of n and negative 5 being decreased by 8. It is 12. And now we need to solve it. And draw the line, change my sign. All right, so this is my variable term now. I'm going to get rid of negative 8 by adding a positive 8. N over negative 5 is left. 12 plus 8 is 20. To get rid of this negative 5, I need to multiply by negative 5 because that's how you undo division. This is a very tiny multiplication sign. I'll make it a little bigger. There we go. So is that one. So those cancel. N's left. 20 times negative 5 is negative 100. So we have an equation. We have a solution. All right. Last one. Woo! I have 9 less than, that means subtract, the quotient of, that means division, a number b and 6 is equal to negative 10. There's that word less than again. If I want 9 less than the quotient of b and 6, that means take the quotient of b and 6 and take 9 less than that. So 9 less than the quotient means take that quotient and take 9 away from it. The order matters when you subtract. So when you see those words less than, that means whatever's first is what's being taken away. And it equals, it says right here, negative 10. Ready to solve it. Whoa, sorry. Got a little crazy. Draw the line, change the sign because it's subtraction. I want b over 6 by itself first because it's a variable term. Add 9 to each side. Negative 9 plus positive 9, gone. We're left with b over 6. Negative 10 plus 9 is negative 1. Now we need that 6 to go away. We're going to multiply both sides by 6. And b is negative 1 times 6, which is